Okay, so let's grind into some mathematics. I hope these explanations have kind of made sense, but I find that the more you play around with this, the more your understanding develops. So even though I don't know if those explanations were helpful or not, I think the best thing is to just jump right in and give some questions underway. So let's just do that. Just to set the stage of how we're going to solve this, so our methodology, we're going to differentiate until we have f double dash x. We're going to find the nature of the concavity, that is the curve, and then we're going to test and prove. So typically the question will be like this one. Does x to the power of 4 have a point of inflection? It's like, okay, well we need to solve that. So let's solve that by differentiating this twice. Then we're going to find the nature of the concavity, and then we're going to test and prove that. Okay, so if we differentiate once, it's going to be 4x to the power of 3. Then we're going to have y f double dash. It's going to be 12x to the power of squared. Now, if we say that this is going to equal 0, we're going to find what x value that's going to be compliant with. So if we're saying if y dash dash equals 0, then there will be an inflection point. So let's make this equal 0. Okay, so 0 equals 12x squared. If we're solving for that, x will equal 0. Okay, so we have a x value. If we put that back into here and make that equal 0, 0 to the power of 4 will equal 0, so y is going to equal 0. So we have a point. 0, 0 could be a point of inflection. So let's test it out. Okay, let's figure this out. Let's try and find the concavity of it. Let's go one to the left and one to the right in terms of our x values and determine the nature of that. And then we can say whether it has a point of inflection or not. So let's put this in. So x is going to be minus 1, 0, and 1. Our dash, double dash, think about that. Let's just rule this up in a nice little table. So if we put negative 1 back into here, that's going to be negative 1 squared, so it's going to be 12. So that's just going to be 12. If we put 0 in here, that equals 0 again. If we put 1 in here, 1 squared is going to be 1. 1 times 12 is just 12 again. Okay. Well, so hang on a second here. We have negative 1, 0, 1. So it goes 12, 0, 12. The concavity doesn't change. Okay. It doesn't go from negative to positive here. So it's consistent. So we don't have a point of inflection. So no. There is no point of inflection at 0, 0. Okay, let's go on to another example. Find all the values of f of x where it's concavity down. Okay, so we want to differentiate this twice. So we already have it, so let's just go straight into 1 dash. That's going to be 6x squared minus 14x minus 5. Let's do the double. 12x minus 14. Okay, so we have this point here. Now we've got to find if it's going to be concave down. Now for that, it needs to be negative. So it needs to be less than 0. So it's going to be fxx is going to be less than 0. So we go 0 greater than 12x minus 14. We're going to put our 14 over here. it's going to be ugly. And then we're going to divide by 12. So at this point, let's change this. 1 and 1 over 6 is x. At this point, where x is 1 and 1/6, that's going to be where it's going to be concave down. Okay, because it's going to be less than 0. And let's move on to our final third one. Quickly, going to make this quick. Find the point of inflection on the curve this. Okay, so there's a point of inflection, we've got to find it. So let's differentiate twice. 3x squared minus 12x plus 5. Let's do double dash. 6x minus 12. Okay, we know that for this to have a point of inflection, this y dash dash must equal 0. So 0 equals 6x minus 12. Let's put the 12 over. Let's divide by 6. So it's going to be 2 equals x. X equals 2. Okay, so we've got that this is equals to 2. We want to sub this, sub into fx. Let's just say that. So we're going to sub this back into our y. Okay, back into our original function. So that's going to be, I like to keep everything nice and neat, 2 to the power of 3 minus 6 2 squared plus 5 times 2 plus 9. That's going to be 2 times 2 times 2 is 8. That's going to be 4 times 6, which is negative 24, I think. Plus 10 plus 9. Okay, so if we put that in, that's going to be 18, 27 minus 24 equals 3. So we have a point of 2, 3 possible inflection. But now let's prove it by checking the concavity. Okay, so let's go 1 to the left and 1 to the right of our x value. So let's say our x is going to be, it's going to be 2. Let's go 1 up, 3. Let's go 1 down, 1. And let's find our y dash dash at those points. So, if you're a little bit confused, I'm kind of doing a little bit of this in my head. I actually need to write this out. I'm going to be putting these, if this is y dash, it should be able to go into this, just here. Okay? So our y dash dash, let's write it over here. Our y dash dash was 6x minus 12. If we put our 1 into there, that's going to be 6 times 1, which is 6. 6 minus 12 is going to be minus 6. If we have our 2 in there, well, that's going to give us our, If we have our 2 in there, 6 times 2, that's going to be 12. 12 minus 12 is going to be 0. If we have our 3 in here, 6 times 3 is going to be 18, minus 12 is going to be 6. Okay, so we do see a change in concavity here. Whoops, I better bring that up. We do see a change in concavity where it's gone from negative 6 to 0 to 6. So we can say 2, 3 is a point of inflection. Easy.